Hello, we are continuing to build our meme vote DApp on Eternity. In this video, we will create a function to vote on a meme with eons. We will also further optimize our contract. Let's start to optimize our contract. The problem right now is that the user has to input the index of the meme themselves. But how should they know what index they need to enter? And how can we prevent that the number is used multiple times? Another problem we're going to have is that we don't know how many memes were already registered. But we need to know this later in our frontend so we can display them all. So let's store how many memes we have. First of all, in our state, we need to store a new key value pair. Let's give them the key meme length, and the value will be an integer. Next, in the init function, we will specify that meme length should be 0 when the contract is deployed. Now let's build a function where we can access the meme lengths. It needs to be public, of course, and let's call it getMemesLength. We don't need any parameter, and we'll return an integer. We want to access from the state the value corresponding to the key meme length. Okay, now we can read meme length out, but it will always be 0. So we need a way to update it. Of course, it needs to be updated in the register meme function, because there we register new memes. Let's create another let binding called index, and this will get the value of our getMemesLength function, increased by 1. And we also need to update the state with our new value for meme length. We do this through our put function. Perfect, and now we can also delete the index parameter. We no longer need it. Okay, that's it. Now let's test this. Now let's try to register a meme. This time we just need the URL and the name, no more index. Let's call the meme length function, no arguments, and we'll get back an integer. Okay, let's register another one. And now we can call the meme length function and should get back 2 memes. Perfect. Okay, now let's build our vote meme function. The user will vote with eons, and the person who submitted the meme will receive them. Again, we'll create a public function, because we want to be able to access it from outside our contract. It also needs to be stateful, because we're going to change the state of our contract through this function, since we want to update the count vote value of our meme record. As a parameter, we just need the index, which is an integer. Okay, let's create the let binding and store in it the meme that we want to update. We can get it through the getMeme function and the index that we get as a parameter. Okay, now it gets a bit interesting. Let's try to give the submitter of the meme the amount of eons the user sent him while voting for him. So basically the user sends the tokens to the contract, and the contract sends a token to the submitter. We don't need to care about how the user sends a token to the contract. This is quite simple. We have a built-in functionality for that, you will see later. So let's find out how the contract can send the user eons. Let's go to the documentation again. Under built-ins we have the account interface. And that is exactly what we're going to need. So to spend token from the contract we can use the chain.spend function. We will need the address where we are going to send the token to, and we'll need to specify the amount that we want to spend. So let's use chain spend. The address will be the creator address from the scoped meme binding that we got one line before. Now, how do we get the amount? Well, if you remember before we found the caller address in the contract primitives documentation, let's go there again to see if we can also find the amount of the call. Here it is, call.value, the amount of coins transferred to the contract in the call. That looks right, perfect. Let's use this, so the amount is call.value, and that's it for our chain spend function. But we are not done with our function yet. We also need to update our meme record. That will be interesting, since we haven't updated a record before. Okay, the vote count needs to be updated. Let's make a let binding for this and call it updated vote count. Let's get the current value from our meme binding and we need to add the call value on top. Then we got the updated vote count. Now we need to update our memes map. Unlike before, we don't want to enter a new one, but actually update the vote count of a meme record inside our memes map. Let's make a new let binding called updated memes and insert our memes that we got from this date. But from the selected meme we need to update the votes. So let's get the vote count through the index and assign it our newly calculated value. Let's use a put function here and store our new memes mapping in this state. A little note here, we are just updating our mapping, but still creating a new memes mapping to replace the old one. Well, in functional programming languages like Sophia, the data types like maps are immutable. So when we update in our case a mapping, we actually have to replace it with a new version. Since the Lima release, contracts and entry points are not per default payable anymore. So if we want to enable the user to spend token, we have to declare them payable. Okay, now let's test this. We compile, deploy, and register a meme. Now let's get the meme. The return types are address string, string, integer. Okay, let's look inside the data and values. Our vote count here has the value 0. Of course, that's what we expected. No voting happened yet. Now let's vote. We use our vote meme function and enter the index of the meme we want to vote for. Now let's put something inside our amount field. If you remember, that's the field where we can send some aeons to the contract. So let's vote with 7 million ethos. This is the smallest unit in eternity, 10 to the power of minus 18. And let's get the meme again. Now we can see the value changed to 7 million. Perfect, this worked. Nice. But to really test if our meme vote function works, we would need another account. So we actually can prove that he got the token. But this is quite difficult to do in the contract editor at the moment, so let's try this later in our frontend. Okay, we're almost done. Our contract handles now all the functionality we need. There's just one special case we are not taking care of at the moment. What happens if a user tries to access a meme with an index that doesn't exist? Let's test this. We can make this call also down here with a contract call to get a little more information. Okay, it doesn't look good. The contract simply breaks without any message. If we look up a key that does not exist in a map, our contract execution will fail. So let's take care of this situation. Let's go to our getMeme function. Okay, the first line stays the same, but now it gets a bit fancy. We can use the switch expression to check if we actually have a value for the index. We now need the built-in map lookup function for maps. So we can check for the value with the index key and turn it over to the switch function. We use map.lookup here because it also returns something if it doesn't find a value for the key that it is searching for. And we use the switch function for pattern matching to detect it and execute the function. These little arrows are error functions. If you want to know more about the switch expression, you can look it up in the ReasonML documentation. There are some deeper explanations. Sophia is based on ReasonML. If we find nothing, we'll abort and display a message. So let's write, there was no meme with this index registered. And if there is an index, the function will return it. Let's test this now. Nice, okay, we got another message this time. Okay, now let's test the other functions in our contract one last time. First, the getMemeLength function. 0, sounds good. Now let's register two memes. But this time I'm going to use real values, since I also use this contract later if everything works fine. So I will use this first meme. Enter a name. And call the function. Now the second. Let's vote for the first meme, I like this better, with 2000 ethers. And now let's get our memes. First, the first one. We have to enter the return type, address string int. Let's look in our data. The vote value is right. Let's check the second one. 0 votes. And URL is right too. Nice job coming this far. We built our first contract on top of the Eternity blockchain. In the next videos we're going to build our front end for our DApp, so that users can actually use this contract. In order to be able to use our contract, we're going to need the address where it is deployed. So copy it and paste it somewhere before you close the window. See you in the next video.